dilution is to weaken or to decrease the concentration. Typically you do this by adding water, which increases the volume of the solution. We know that the relationship between the volume and the molarity is that as the volume increases, the molarity decreases, what we were just talking about with dilution. This is an inverse relationship, which brings us to the formula for dilution. M1V1 equals M2V2. Problem 1. What volume of a 15 molar stock solution of HCl is needed to make 500 milliliters of a 5 molar HCl solution? To solve this problem, we need to identify what the initial concentration is, what the volumes are, and then we can plug them into our formula. So what volume of 15 molar stock solution? So we know we have in stock or on the shelf 15 molar solution. What we don't know is what volume of it to use. So what volume do we need to make 500 milliliters of a 5 molar solution? So we know that our new concentration is 5, and the volume that we want is 500 milliliters. Now the units for volume here can be milliliters or liters. It doesn't matter as long as they are both the same. And so then we solve for our volume. So we have 5 times 500 divided by 15 gives us 167 milliliters. Now that is 3 significant figures. We go back to our problem and we find our least number. So we had 3, 2, and 4. So we need to round this number to 2 significant figures. So it would not be 167, but instead it would be 170 milliliters. Problem 2. What is the molarity of a solution made by diluting 100 milliliters of a 12 molar sulfuric acid, or H2SO4 solution, by adding 200 milliliters of water? Same idea, and the thing that will help you out is this word of. Just like in math class, that word of means to multiply. So we have 12 molar solution, we have 100 milliliters of that solution. Now we have to make sure we read the question carefully because it says that we're going to dilute the solution by adding 200 milliliters of water. That is not the final volume. That is how much water we're going to add. We started out with 100 milliliters. So what's our final volume? 300. And what will be the concentration? So we take 12 times 100 divided by 300, and we get that the new concentration would be 4. Now, how many significant figures do we need? We go back to our original problem. We have 4 here, 3, and 4. So we go by our least number, and so there we need 3. Be 4.00 molar would be our answer. Even though you have a big M here, you must have your unit be a big M here. This is a unit, comes after the number. This is the variable you used in place of a number in the formula. So this M is not the unit, this is the unit. Alright, so at this point, stop the video and do the practice problems. The answers to the practice problems are 0.13 molar, 0.1 molar, and 50,000 milliliters, or 50 liters. If you got the problems correct, then you may stop the video now. If you did not, please continue watching while I solve the problems. Question 1. 25 milliliters of water was added to 125 milliliters of 0.15 molar. So what is the concentration, the final concentration? So again, we have 0.15 molar of, 225 milliliters of 0.15 molar. So those two go together. And that's equal to some new concentration, times the final volume. Now we added 25 milliliters, that was not the final volume. The final volume is 150, 125 plus 25. And so then we solve for M. 0.15 times 125 divided by 150. And so then the molarity is 0.125, but we started off with, we have to go by our significant figures. And we started with 25 milliliters here, that's 2, 0.15 is 2, and 125 is 3. So our least number of significant figures is 2. So we round to 2. So it will be 1.13 molar. Number 2, we had 100 milliliters of 0.15 molar sodium hydroxide. Our final volume was 150 milliliters. So what is the concentration? So again, our concentration initially times our initial volume equals our new concentration times our final volume. And we solve for M. And so we get 0.15 times 100 divided by 150, and we get 0.1 molar. Now in the problem, we were given only one significant figure, so we can only keep one in our answer. So it remains 0.1. Question 3. We had 0.05 molar HCl. We wanted to know what volume of that we needed to get 250 milliliters. Okay, so we had a 10 molar solution, and we had 250 milliliters of that. What volume are we going to end up with of a 0.05 molar solution? So again, these two go together, that word of connects them, so we would have 10 times 250 equals 0.05 times our volume. And so we solve for our volume. 10 times 250 divided by 0.05, and we get 50,000 milliliters. And I know it's milliliters because that's what I put in. And so the conversion to liters, of course, is to divide by 1,000, so that would be equal to 50 liters. The problem did not ask for liters. You could certainly leave it in milliliters.